Here we are going to see about compensation without syntactic filter with the syntactic filter. This is model the system having without syntactic filter. Here I can see that the amplitude voltage, that means amplitude of that grid will be 415 and frequency will be 50. Then this is a series resistance and inductance 0.1 and 0.15 millihenry. Here that series resistance will be 0.4, 3.55 millihenry. Then this is a 3-phase diode rectifier with the RL load. It's going to act as a nonlinear load. Here you can see another resistance and inductance. This is load resistance and inductance 60 and 20 milliamp. Here we are going to measure IABC, VABC and VABC nonlinear load. That means here we are going to measure VABC, IABC. Here we are going to measure VABC at nonlinear load. Next you have to check the output current, voltage and the load voltage. Here we can see that grid voltage, load voltage will be have same sinusoidal, but you can see that grid current will be not sinusoidal. You have to check the THT of this one. Further go to this discrete, go to tools and then go to FFT analysis. Here you can see that this is a current waveform. You can use same as maximum frequency and then click display. Here you can see that the THT of the grid current will be 24.21 percentage. Not that means it's not less than 5 percentage. So it should be improved because of this nonlinear load. We will get that the harmonic in the system. So we have to eliminate this harmonic in the source by using syntactic filter. For that you have to use this model. This model consists of syntactic filter. Here you can see that inverter with the capacitor and also that syntactic filter is supplied via solar panel. Here the solar panel and then this is boost converter and then output voltage of that boost converter is controlled by means of this PA controller. Here we are going to maintain voltage across that DC link voltage is around 500 to 800 not to mitigate the harmonic in the system. Now I simulate this model and then this is a control logic for that inverter in order to improve current harmonic in the source. Now I am going to simulate this model. Here we are going to measure grid current, load current and the syntactic filter current. This is grid current, this is load current and the syntactic filter current. This is grid voltage, load voltage. The syntactic filter going to be activated in here at 0.05 second. After that you can see the variation in the grid current, nature of the grid current. That means the nature of grid current change to sinusoidal. Now we can see that syntactic filter is activated here. That means it's going to be connected in the system the time of 0.04 second. After that you can see that because of including of the syntactic filter, the syntactic filter injects some current in the system in order to make that source current then near sinusoidal. You can see that this is a way that means grid source current nature is changed to sinusoidal. But here you can see that this is the nature of load current. Because of including that syntactic filter in the system, current harmonic is eliminated in the system. This is a purpose of syntactic filter. Moreover, that the syntactic filter is derived from that PV panel. And also you can check that this is a grid voltage and load voltage. There is no changes in the grid and load voltage. Next you need to check that THT of source current. For that we go to measure that FFT. Here you need to measure that the FFT of the source current. Now we can see that source current will be around 0.58, but without syntactic filter the TH level is around 22.5. So it can be measured here. That means here you can see that for this the active filter will be syntactic filter is activated here at time 0.04. After that the current will be the nature will be sinusoidal. Before it will be have some harmonics. So this is around 24.21. After that we have to measure THT. It will be 0.59. It reduces from 24.29 to 0.59 percentage. The harmonic level in the source current will be eliminated by means of that syntactic filter.